today the plan was to get back here. There we go. Okay, so the determinants and matrix inversion really work together. I'm going to show, I realized I didn't show you how to do determinants with the calculators directly, so I'll show you that. And then we're going to talk about, from 5.3, the last two homework questions involved coding, taking a phrase, inverting a matrix, sort of making a code, and then decoding with it. So I'm going to walk through an example like that. It's not that hard, but I'll walk you through it. And it kind of uses determinants. We'll talk about those. I looked over 3.7, which is Cramer's rule. I remember it mostly because that was the name of my high school driver's ed teacher, Chuck Kramer. He was a guy you 40 years later, I still remember him. I can still see him. He also, it was interesting. He was a client of mine, actually of my boss's, when I was doing financial planning. So 20 years later, I went and I said, "Can I go on the appointment with you?" Because it was down in Corvallis, up in Portland, Oregon. So I met my old driver's ed teacher 20 years later, and he still looked the same. So anyway, one lesson I teach you that he taught me is, when we met him, he was like running out of money, because he says, he's a portly guy. He says, "I've never been real healthy, so I didn't think I'd live that long." He says, "I'm still going, and I gave all my money away to my grandkids and this and that, and can you guys help me? I need, Social Security's not enough." So, but he did tell me, he says, whatever I taught you about driver's ed, yeah, use that. But he says, remember, you may live longer than you think you're going to live, so save your money. So even if you're not real healthy, you might live longer than you think. So, like my grandmother, we thought she'd go, but she made it to 102. So, but she was good with her money, so she always had her money. All right, so Cramer's rule, is really just another method to do the same thing we already can do with either reduced row echelon form or what we can do with 5.3. So it's like a third method, and it only works with 2x2 matrices. And again, what we need these matrices for is for larger matrices. I was hoping the content would take us to like an application, but it doesn't. So what I'm going to do is to say, let's do Cramer's rule, but let's not do Cramer's rule. Okay, so there's 4 homework problems in there. Do it by the methods that we've already learned. And I'll show you an example. Use reduced row echelon form. When we come to the exam, you're going to be fine. I'm not going to, I get the ability to change 20% of the test. If there's a question that forces you to show how to do Cramer's rule, I'll change it. We're not going to focus on methods. We're focusing on applications. So that's what we're going to do today. So the homework's still there, but that gets moved up. What that's going to allow us to do is and then because the next stuff we start focusing on is something completely different. So we're done with matrices. 7 is sets and cardinality. So this is like set theory stuff and counting. The reason this will set us up for what we do in basic probability, chance of something happening. It's completely different stuff. So I think it'll make a nice transition. We'll just talk lightly about this. So we'll be done with matrices. We get into basically probability and set sort of stuff. So, and we're sort of just, the sets are forming a foundation for something. We're not going into it deeply. We're taking 2 sections a day. And then we'll do our probability after spring break. So here's another thing is, again, I know not everybody's here, but hopefully those who are not here are at least listening to the recordings, at least the beginning of the recordings, because that's usually where I put my announcements. But I from time I get people, "What are we doing?" I said, "Have you been listening to the recordings?" No? Well, you got to. If you don't come to class, listen to the recordings. So here it is, over spring break. What I will do is, if anyone who didn't finish up any part from exam 1, again, it's all closed up. We're not going to test you on it again. But if you wanted to go back and do some of the homework, because there's a few that sort of studied for the test and maybe they did all right. If you need to finish up any prior homework, during spring break, I will do a week where I will let it be available, but only if you've made progress here. I'm not going to sacrifice progress here, which is going to result in a test where you could hopefully do well on something that's, maybe 3% of the grade, because you're not going to get tested again. We're not redoing a test 1. So make sure you're on track for test 2, but I will also make that option. You just send me an email. I'll check, oh yeah, you're on track. You've gotten at least through the matrix stuff. Okay, I'll go. Want to work during spring break? Great. I'll open up those assignments. And yeah, maybe you had 1 or 2 you wanted to get a few more points on. That's fine. Or maybe your motivation is you wanted to learn something. Some people do that. Actually, I like it better when I'm motivated by trying to learn something. But, okay, so let's go back. We're going to finish up this last part that we didn't really, we were getting crammed on time, so I either did it lightly. Let's see, where were we? Okay, so yeah, this thing basically, remember, this procedure of using the determinant's not really easy. And when we get to 3 by 3, there's, the sort of the by hand methods are so inefficient. We don't want to use those. So we did an example. Let me so I think we got through did we get through, does this look familiar? We talked about inverting matrices, right? We just put it in, and then we use our calculator, pull up the matrix, and do the x to the minus 1, the inversion key. We'll be doing that again. Let's see, where did we leave off? We did this one, and this is the same thing that Cramer's rule addresses as a problem just like this. You could do it with reduced row echelon form, or you can do it as setting it up. I'll start here just as sort of as a reminder. We could set this up as a matrix A, which is the coefficient matrix, which would be just the numbers in front of the variables. So that would be 1, 1, 1, and -1. And then that's the way we set this up. It's multiplied by the column matrix xy. Oops, xy. So that's how we get the variables. And that's equal to the B matrix, which is the column matrix of just the answers, 2 and 1. Okay, so this part was A. This is what they called X. And this we called matrix B. So we get a sort of a formula, A times X equals B. And the way we solve this is we took the inverse matrix of A, multiplied it by both sides, right? Because equations, we can do that as long as we do the same thing to both sides. The inverse of A times A is the identity matrix. It's basically 1. So we're left with X equals A times the identity matrix, or the inverse matrix of A times B. We do this on our calculator, and what we get is we get a column matrix that basically tells us what X and Y are. Okay, and we're going to do that sort of again. But that was a method. We could have also used reduced row echelon form, and we would have got the same answer, right? We could have done the augmented matrix, which would have just been 1, 1, 1, -1, 2, and 1, and do reduced row echelon form. And so, why do we use the other one? Again, a lot of this is getting into is just techniques, mathematics that you can do. So this part I'll do, but I'm not going to go to a third method that does the same thing, because unless there was some purpose to do it, and there isn't. It's not like going to do anything magical for us down the road. Okay, and now we're to this one. Okay, and let me pull up my calculator. I forgot to get that open. begin this example, and we'll do it. We'll get on track. This is really the last thing we need to do for 2.5. Then I'll pull up Cramer's rule homework. We'll do a couple of them together. I'll just show you. Enter it in, reduce row echelon form. Boom, you got your answer. You're done. So let me make this bigger. Oh, waiting for the calculator. That's right. It's probably going to make me log in. No, it worked. Okay. Here like that. And then let's go with the slideshow. Okay. So the way this works, secret spy stuff. So this is one of the uses of matrices. And again, I was studying this stuff 40 years ago, and this is what sort of interested me in math. However, I found because I was actually got pretty good at this, but the only place I could get a job was secret spy stuff, and I didn't want to go in the military and kill people or get killed or, Anyway, that's not who I wanted to work for. Reagan was in office at the time. I've come to appreciate him more, but at the time I was not a Reagan fan, so I didn't want to be in the Reagan administration. So, but actually was, in comparison, not bad. So what we're going to do is, how this works is you've got a phrase, a message, abort mission. So we want to get this to our folks in the field, but we don't want the enemy to be able to know what we're sending, right? So we send it out Morse code or something, but we don't want to send abort mission. So what we do is we first take those letters and we turn them into a code. And they don't provide this. I just used an Excel program to kind of do this. The code is 0 equals a space, 1 equals A, 2 B. So we change the letters into numbers. Okay, so this might be helpful because of there's the last two problems. I think one of them, they have you take a different message, turn it into a code, turn it into a cipher, which is a scrambled code, and then decode it. The third question, the second question, what they do is they give you a scrambled code with the key, which I'm going to show you, and then you have to decode it. What does it say? Okay, so you'll need this sort of somehow, or if you're good with the alphabet, you know that T is the 20th letter. Well, actually, it's not the 20th, it's the 19th, but because they have the space, any space between words is going to be 0. So we could code it this way. Actually, it is. Oh, yeah. So T would be the 20th letter because we start with 0 as a space. So if you're good at that. Now, you could also code it differently as long as your agents in the field knew it. So there's all sorts of things. We could have started with 100 or 99 or whatever, but this is what we're working on. These are how we decode. How we're going to code this thing is we make a matrix. So abort mission is, so 1 is A, 2 is B, O is the 15th letter, 18th, T is 20, and then there's a space here which is 20, or sorry, is 0. Let me see if 0 comes from the space, and then M is the 13th letter. So we kind of just do this. What we're going to do is we're going to encrypt using a 2x2 invertible matrix. Okay, so first thing, I can't remember, yeah. So again, we could change this code. This is our key. Our folks in the field have the key, but we could change that. And as long as it's a 2x2 invertible matrix, it will always work. What we're going to do is we're going to turn the numbers that we have coded, because if we send that out, people who know this, easy to decode. We're going to take this and invert it, and we're going to take this and make it into a 2x2. I think, okay, I didn't do it. Good. So the way we do this is we're going to make not a 2x2, but a 2 by whatever. So I'm going to turn this code into a 2-row matrix. So it's the 1 goes here, the 2 goes there. So I've used up those two. Then the 15 goes here, the 18 goes below it. So we're kind of scrambling things, right? But we know how we're scrambling. And then we've got a 13, and then we've got a 9. So So I'm just going through and kind of going through each one. And then I've got a 19 and another 19. Then I've got a 9 and a 15. And I've got a 14. Uh-oh, I need one more thing. What could I put there? Any ideas? 0 for a space, because there's a space at the end of the word. So that's what the cool part of this is. That's why we do it a 2 by 2, because you'll either end up right there, or you'll have one extra space, right? Because everything can be divided in half. It might be one left over. If there is, there's a space at the end. Okay, it's not going to throw anyone off. So that's the matrix. What we're going to do. So I should have looked at this before, because I can't remember which way it works. We're going to invert this matrix. So it's kind of like I'm working without a net. I don't know if this is going to work, but it should. So we're going to take the inverse of this matrix. We're going to multiply it by, oh wait, no, decipher using the, oh sorry, I got to remember how I did this. It's kind of like I did it enough times, I thought, I'll remember this. No, I forgot it. We're going to take this matrix, the key, and multiply it times the matrix. Okay? It'll make a different matrix, right? Because if we take two matrices and multiply them. So what we're going to do is we'll take this. It probably doesn't matter which side, but I'll put this one here. So we'll call this matrix A. We'll call this matrix B. So what we're going to do is we're going to do A times B. We'll get some new matrix, C. And then C is going to be sort of scrambled or coded, because you can't, if you come back here, you'll see, actually it won't even fit in here. We'll get some of the numbers maybe like 98 or something, which aren't even on our code. But we'll be able to uncode it by doing what? Multiplying by the inverse. Because what does the inverse do? It undoes what the other one did. So that's the whole key. So let's give this a try. And actually, this teaching method I use is from Dr. Crittenton, who was dyslexic, and that's my professor from Portland State University, who basically got me through school. I was about to drop out because of math, and he got me through because he taught this way. And he even told us, he says, what I try to do is I try to forget anything I know about math, or try to think that, just remember enough like I just remembered it or just learned it, because then I can explain it better. He says, if I make it now smooth, you won't learn. He says, you'll learn better if, where is it? Where is, oh, it's over here. You'll learn better. And that's what I need is, so like, when you make a mistake, that's what you need. How do I figure out I made a mistake, and how do I undo it? So that's what I try to teach here as well. Or sometimes it looks like I don't know what I'm doing, and truthfully, sometimes I don't. Okay. But I know how to get back. Okay, so what we're going to do is we'll go second matrix. We're going to enter two matrices. I'll enter in A, I'll enter the 2 by 2. Oops. Quit. Let's see. Clear, clear. Go to matrix. Remember, we have to go over to edit. This is kind of, get used to this, because practice a few times. 2 by 2. And our matrix was, let's see, 2, 1, 3, 4. 2, 3, 1, 4. Okay, I'll do it this way. 2, 3, 1, and 4. And again, we could use any matrix as long as it is invertible. So you'd want to test it first, maybe. So let's do that. Second matrix. Actually, second quit. So we're here at this screen. Second matrix. I'm now going to use the name. I'm going to pull this up. I want its inverse, so I do this. Okay, it's invertible. Okay, that's all I needed to see, is that I can get an inverse matrix. I'm going to multiply the regular matrix times what I got, make that B matrix, get something new, and then I'll use the inverse. If you'd like at this time, since this is the inverse matrix, remember sometimes it's nice that you could store that, or you could just use A inverse again. So I think I'll stick with A inverse instead of having too many things stored in there. But remember, there is a way to store a matrix. We'll store the result of our coding. So then let's come back here. We're going to put into matrix B. We're going to edit this other matrix. So let me shrink this down a little bit so I can see what I'm putting in. So this is our code. And again, if it was a long code, it could be a pretty long many column matrix, right? So I want to put this in. This is a two rows by 1, 2, 3, 4, 5, 6, 7 columns. And again, I just go ahead and enter this 1, 15, 20, 13, 19, 9, 14, and I'm down here, I've got 2, 18, 0, 9, 19, 15, and 0. Okay, so that's our matrix. Again, if we want to get more complicated, we could do this. We could do a larger matrix. There's a lot of things we could do. We could do double encoding, but this is the nice thing of matrix. We turn them into numbers. We can transform it into something else, and then we can untransform it by using inverses. So now that matrix is there, what I want to do is this. I want to take A times B and get a new matrix. That's what I send out to my spies, abort mission, but nobody else can know because you're going to see it's going to be so funky, you can't decode it with this. And then we'll be the spy on the other end. How do we decode that? We'll use the inverse. So all my spies carry their TI-84 with them into the field. So we go second quit, right? So to code it, to make the code, we're going to take matrix A, which is, okay, so now we're at names. We're going to use matrix A. Now this is another thing, is I've seen some of you have been multiplying. You can't just put two matrices together and it knows to multiply, or you can't even use parentheses, I don't think. I think you have to use the multiply button. And some of you may have already figured that out on your own, but you helped me figure it out. I forgot about this. So we're going to multiply this times the other matrix, matrix B. Oops. And again, it works. So I could I multiply B times A? Let me just ask you this could I? Why not? Because B is a 2 by 7. I can't take a 2 by 2, because remember, those two middle numbers have to be the same. So that was the other thing, is now I know I'm doing it the right way, because I couldn't do it the other way. I can't take B first and then multiply by A. I get an error, but that's okay. So sometimes we just do it. Oh, I got an error. Just switch it. But I can do it A times B, because there's 2's in the middle. There's a 2 by 2, a 2 by 7. Those 2's, we're going to end up with a 2 by 7, right? Okay, I think I just hit enter. So I've got A times B. I'm going to enter it. Notice I've got this matrix. Could I decode this? No, 95 is not one of the letter codes. So you can see it's completely sort of scrambled around. The only way to unscramble it is to know what matrix I multiplied by, and I'm going to multiply this by the inverse, okay? So this is in the homework. This might be part of what they want. What is the coded matrix? I can't remember exactly the question, but so then you'd enter this. This is the code we got. They'll give you the 2 by 2 matrix to use. You'll have to decode. Okay, so I'm going to save this or store this, right? This button down here, store. I'm going to store my coded matrix, second matrix. I'm going to store that in C for code. It works. And I do that, and now that matrix has been stored in C, so I can send that out to my spies. My spies get it. What do they do? They're going to take this matrix, and they're going to they're going to take the inverse of the key, the inverse of A, and multiply it by C. So then they come back. So everything's stored here already. Go to my matrix. I'm going to take A. I'm going to take its inverse, right? Because the first time I took A times B, gives me this code. If I take the inverse of A times the coded matrix, I should get back to where I started. Should, hopefully. Times, and now this time I want the coded matrix, which is C. That's all I got to do. And there it is. And if you'll compare that over here, we got exactly the same matrix back, right? Now my little spies out there, my little minions taking over the world, take this and they use my, they have this over somewhere and they can decode it. Okay. They also have to know that it goes this, 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 this. So there's, there's a little bit of coding within the code. Even if someone gets it, they, you don't go this way. So there's all sorts of things. And again, you see in the secret spy things, they take a book and, you can even do it, the third letter and stuff. You can get more complicated with this, but there's all these types of things using matrices that we can do. We can easily code it to something strange and unintelligible, and then get it back with that inverse. So that's what those last two questions are about, is this method. They give a few explanations. That's sort of how I picked out, but I just wanted to go through and, emphasize how you come up with this matrix from the code or the phrase that they're going to use, and then it's an application. Any questions? Yes. They have two of the questions. I think the first one, they're more interested in what will the code be. So I think that's all it is. The second question, they give you the code and then you have to decipher it. So you have to put in the phrase that they have. So they give it to you both ways. That's why they gave you two questions. So just notice that when we're making the code, we use the matrix they gave us. When we're decoding, we use the inverse of the matrix they give us. I think they use this one, the same one. Again, if we want to code differently, we just change this. As long as it's invertible, we can make these numbers anything we want, just as long as we know what it is, and then the key would be different. So if there was, we got a double agent, let's change that key, and then they don't get anything intelligible. So that'll help you with those last two homework problems. I think it's a pretty good, I always like to, when we teach you something, leave you with an application of how you can use it, because that's really what you're taking these classes for, is how do I use this? Maybe not for business unless you're into espionage or something. But yeah, maybe you need to hide some company secrets. You don't want the competition to get your secrets. So it doesn't always have to be spy stuff, but corporate spies. So that's the last of what we were finishing up with. What I wanted to show you also on the determinant, if you ever need to get the determinant, most of what they have the determinant for are just 2x2 matrices. So I'll use A as an example. If you come over to math, there's this DET that will give you the determinant of a matrix. It's got to be a square matrix to get a determinant. And I think in the homework they ask you for the determinant, but it's always a 2x2. So you go determinant, and then you have to go matrix A, or whichever one you're going to use. Close the parentheses, and then now we've got the determinant, which is just a number. And remember, we could use that number times the matrix 1 over, if we take that number and divide it into the matrix. So we took 1/5 multiplied by matrix A, we actually get the inverse. So it's a quick way to get the inverse, but I say quicker way, just use that button, right? So I'm all about, let's make things as simple as possible. Why have 50 ways to do the same thing unless they help us in some way? And this doesn't help us. It's just before calculators, that's what they had to do. And if you do larger matrices, getting the determinant is really a pain. Even a 3 by 3, so 2 by 2 is not too bad. You just multiply the diagonals and subtract them. Not too bad. But with a 3 by 3, you're multiplying three things. There's multiple multiplications and additions and subtractions. And it's like, for what? I could just use that inverse button to get what because that's all it gets me. That's all the determinant. Cramer's rule uses the determinant as well. So I think they said, well, we taught you about the determinant. We want you to use it more often. But again, technology takes care of it all for us. So that's what I mean is the technology of these have been maybe 20 years. Math curriculum's still like 40 years old. So they're teaching us old stuff. They don't want to let it go. So, but I'm going to let it go. Okay, so there's that part. Let me go into our WebAssign and I'll just show you what Cramer's rule looks like. And then we're not in any rush, then we'll kind of have time for any additional questions. If you haven't picked up your exams, I do have your exams. What am I doing? I think that's right. Are any of you looking to get into like maybe the insurance field, business-wise? If you got an offer, would you turn it down? Probably not. I wasn't looking for it. I worked in the insurance field for 9 years, on sort of on the sales side, but I was the inside guy. So what we're going into on probability is all about, chance of getting in an accident stuff. So it's used a lot in those type of fields. Or risk management. If you're going into risk management, you'll want to look at the probability. Okay, we're 3.7 Cramer's rule. I'm just going to show you. It's really nothing new. So the types of questions they have is they give you a matrix. You could do this with an augmented matrix, right? Sorry, it's showing you the answers too, but so you could set this up with a 1 by 1 by 28, 1, -1, 22, and then just in your calculator do reduce row echelon form, and it'll give you the answer. It'll give you a probably, what does it give you? It gives you 1, 0, 0, 1, and then gives you these numbers here. It'll give you 25 and 3. So x is 25, y is 3. Solved it for you. Cramer's rule will give you the same answer, but we have to, and they didn't even have a PowerPoint on how to explain, so I could go in the book and I'd have to take some things out, but I could see it's using determinants. So you get the determinant of it. And again, the other way you could do it is you can make this as the A matrix, take its inverse and multiply it by the answer matrix, and you would also get the same answer. So that was the method we just started using in 5.3. So again, two different methods. I think that's plenty. You could use whichever one you want, just get the answers. And remember, if it doesn't get into reduced row echelon form, like the last answer is 0 equals 1 or something, then it's independent, not independent. It's weird they put it so. So there is no solution. And then they have these down here, and again, they give them as decimals rather than fractions. But again, it's the same thing. You're just setting up an augmented matrix, reduced row echelon form will give you your solution. So all of these questions involve that. There's 5. Actually, I thought there was only 4. There was 6, and I took one out because what they did is they put in a letter that would force you to have to use the Cramer's rule. And I says, let's just do ones where, 2 by 2 2 by 3 actually, augmented matrix, you'll come up with those answers. I don't know how many decimal places, but maybe under 4 or 5. It should probably get it right. But yeah, and then if you're interested, the last one does a little explanation of what Cramer's rule is, and it looks pretty complicated, right? You got to get determinant of this, determinant. I remember it's not easy, but using reduced row echelon form is. And so that's how I'm going to want you to do it. If there's any question on the test with Cramer's rule, you could do the same thing. Okay. So that's like 5 questions. More practice at either using reduced row echelon form or this other method with inverses, or both. Switch it up. You'll be fine. But questions? You good? Yes, sir. Yes, and then I multiply by, so this would be, remember we did AX equals B, so I did a 2 by 2, this is XY, and this is the, B would be the answer matrix. And so what I can do is take the inverse of A times B, so I just kind of, made it 1. So here's the A matrix, I take its inverse and then multiply it by the answer matrix. That will give me the answers as well. That does the exact same thing as reduced row echelon form. Me, I'd like to just go with reduced row echelon form. Just put one because then I got to put in 2 matrices, right? I got to go to the screen. I got to pull up this. I got to do the inverse. I got to pull the other one, and then I get it. This other one, I just put it in as 1 matrix, and I push 1 button, and I'm done. That's me. But, and again, I was hoping that there'd be more application. This one with the inverse, again, the application of the coding, I think that's enough reason to know how to do it as a method. That, again, I wouldn't use it on this, but I could use it on the coding, because it gives me that inverse sort of transform it back. So that's kind of a good application. But yeah, and then just go through it. And then remember, not everything can get into reduced row echelon form because there might not be a solution. Might be parallel lines that don't intersect, because that's really what we're dealing with. We're dealing with 2 lines here. We're finding that place where they're intersecting. Okay, and when we get into a larger matrix, it's sort of the same thing, but we're maybe in 3 or 4 or 5 dimensions, so it's hard to visualize what's going on. But we're getting a sort of an intersection. What point in space gives us the best or a solution that fits with everything? And sometimes there isn't one because we got parallel lines or something, and so that doesn't come up. Make sense? So next week on Monday, we will get into the stuff with set theory, and that will sort of form the basis, and counting theory. It's kind of like permutations. How, I got 7 books. How many different ways can you arrange those books? That kind of stuff that you may have seen before, maybe not. But that will set us up for when we come back from spring break. Next Friday, we'll finish up anything we didn't, or have it as a work day, or start spring break early day, whatever your plans are. But we'll record it. We'll take a week off. Again, if you need to catch up on anything, it's there. If you would like to do anything from exam 1 homework, please get up to at least this part. Get through the matrix stuff, and then I'll let you work on the other. Otherwise, I'm going to say take your spring break and get on track with the matrix stuff, because I want you to do well on test 2. That's where the points are. Points are not in the homework as much. Remember, each set of homework's worth about 5% of the total grade. Each exam's worth 25%, I think. I don't know. I'd have to look at the syllabus, but it's in there. We have 3 exams. Yeah, I think each of the exams are worth 25%. That's 75. These are homework's 15%, so that's 80. That's 90, and then 10% for the quizzes. And the quizzes, remember, is just study for the tests. Do the study work on it. So that'll get you through. All right. You have no questions. I have no answers. So we're good. So we could basically start office hours early. If you want to work on homework, you're welcome to. If you want to head out, but try to get matrix stuff all in line over the weekend. Bring any questions next week, and we'll go from there.